Hi guys, welcome to Geeks for Geeks practice. So today we are going to see a question that was asked yesterday in problem of the day. So let's go and have a look at it. So the question says flattening a linked list. Now in order to understand this question better, let's try to go to the whiteboard and understand this in detail. Okay, what does the question want in output and what is it saying? Okay, so let's proceed. Alright, so as you can see in brief, the question says flattening a linked list. So first let's try to understand what is a linked list. So the very basic implementation of linked list is a singly linked list that has nodes which contains two things, data and address to the next node. Similarly, this will again have data and address to the next node. And let's say if this is the last node, then this will be pointing to null. All right. So this is how a singly linked list looks like. So given a linked list of size n, where every node represents a sub-linked list. Now this is something different. Like if you observe this particular input, it is a customized linked list. Okay, let's try to observe like how is this? Like what is the structure of the node in this case? So over here, let's say if this is a node. So apart from data, we have two pointers, a next pointer pointing to the next node and a bottom pointer to a linked list where this node is head. So basically there will be one more bottom pointer to another linked list. Okay, so there will be nodes over here as well and so on. Like all of these will point to null, the next pointers of these particular nodes. So if you carefully observe for 7, there is no next pointer, so it's null, but bottom pointer is pointing to 8. Similarly for 8, bottom pointer is pointing to 30, but next pointer is pointing to null. So I hope by now you have understood the structure of the customized linked list given in the input. Let's try to read the question further. So each of the sub linked list is in sorted order. Let's try to see that. So this is in sorted order. This is also sorted. This is also sorted and this is also sorted in itself, right? 5, 7, 8, 30 is sorted. 10, 20 is sorted in itself. 19, 22, 50 is sorted in itself. And again, 28, 35, 40 and 45 is sorted in itself. So what we need to do, we need to, sorry, we need to flatten the linked list such that all the nodes appear in a single level while maintaining the sorted order. So if you observe the output, this is basically a single level. Due to the lack of space over here, we have come to next line. But if you observe the output, it is a single level while maintaining the sorted order. For my viewers who have already done merge sort algorithm, they must be aware of the merge process, right? Like two sorted arrays are passed and in return we get a single sorted array combining the elements of both the sorted arrays, right? So something similar we are going to do here, not exactly same. So let's say initially we consider these two linked lists. Just a second. This and this. Let's name it as L1 and L2. What we'll do, we'll pass this L1, L2 to a merge function which merges the elements of L1 and L2 and returns a sorted L3. Okay. So L3 contains all these elements in a single level in a sorted order. Now for again this L3, I'm going to pass this linked list and L3 to merge function, and this returns me, let's say, L4, which contains all the elements from here to here that are in single level and in sorted order. Now with this L4, we are going to finally take this linked list and again we are going to call the merge function on them. So if I call the merge function, I get the final L5, which stores all the elements of the given input in a single level while maintaining the sorted order, right? To be more precise, in a single level while maintaining the sorted order. So I hope approach is somewhat clear to you, like an overview you have got, right? So now let's try to find out how to implement this merge function. Okay, let's see that. After that, we will see that how we are doing these operations, like giving back the sorted means the combination of L1 and L2, like it becomes L3, right? So basically what we are doing, if you observe on a broader level, we are taking these two, giving back, again we are taking all of it, then again giving back, then finally taking. Basically, we are trying to transfer our, or rather, I would say, when we have the last two linked lists, okay, let's say when we have these two linked lists, when we combine them in one sorted linked list with the help of merge function, we again go back and find out, okay, fine, what if, what sorted linked list I'm going to get at single level in sorted order if I merge these two, right? Like all of this and this. So if you observe what is happening, again after doing this, we are going back. So how we are going to do this, like sorting, maintaining the combination of nodes in a single level and going back, how we are doing that, we will see that. Okay, that will be basically a recursive function. We are going to see that. But first, let's try to see the implementation of merge function. Okay, so this is how your merge function is going to look like. Okay, we have two nodes passed. Let's say initially these are the nodes which has the data 19 and 28. Okay, just for explanation purpose, I am taking this and this linked list. Okay, so I have basically node A represents to the node of 19 as data and node B represents to the node of 28 as data. Okay, I have taken a cur, okay, which initially has the data as -1, and there are two pointers as we know, the bottom and next pointers. There is one more variable res that points to this cur. Okay, now what we are doing, I'll explain. We are checking if a, while a is not equals to null. Okay, we are checking, to be more precise, while a not equals to null and b is also not equals to null. So basically they are not null, right? Because it is pointing to this node and this is b is pointing to this node. Okay, a is pointing to this node, b is pointing to this node. So none of them are null. So we go inside, and in an overview, what we are doing, we are comparing this 19 and 28. Okay, if you see the data, if 19 is less than equals to 28, what we are doing in our cur, okay, which is basically this, in our cur, this is cur and res is also pointing to cur. So in our cur dot bottom, I am having the node for 19. See, I'm just writing the data, but it is actually the node for 19. Okay, so I have it, and what I do, I remove my cur from here and make it point to here, because I'm doing, first of all, I assigned cur dot bottom equals to a. So cur dot bottom started pointing to this node 19. After that, I moved my cur. Basically, I updated my cur with cur dot bottom, so it came over here, right? And then as my task for 19 is finished, now my a starts pointing to this 22. So that's the reason I'm doing a equals to a dot bottom. This is somewhere similar to merge process of merge sort, but not exactly the same because it is the implementation of linked list over here, right? Fine. So what we do, we again compare, okay, because a is still not equals to null and b is also not equals to null. So is 22 less than 28? Yes, it is. So again the same operation. Cur dot bottom is now going to point to 22, right? Your cur moves from here to here, right? And A is now again moving from here to here, right? So A is over here, B is still over here. You again check, is 50 less than equals to 25, because this while condition is still true. So if you check, right, because A is not equals to null and B is also not equals to null. So you check, is 50 less than equals to 28? That's false. So you come in the else part. You do cur dot bottom equals to B. So now the bottom pointer of 22 is going to point to 28 node. you move shift curve to curve dot bottom and you place this B pointing to over here. Again, you are going to compare 50 and 35 because while condition is true. So you're going to compare 50 and 35, right? So this 35 will come over here because of this else part, right? Curve dot bottom equals to B. Curve equals to curve dot bottom. So curve now comes over here and your B shifts over here, right? You compare again because this while loop is still true. 50 and 40 you are going to compare. So is 50 less than equals to 40? That's false. So you go into else part. You have curve dot bottom equals to B. That's 40. You update your curve. Curve comes over here, right? And after that, you point your B over here. Okay. So now again, while loop is true. So you have 50 compared with 45. So you go into this else part. You have 45 over here. Your curve starts pointing to over here, right? Now your B is starting pointing to B dot bottom. So this has null, right? This 45 node, if you consider, its bottom pointer has null. This time this while loop will become false because this B is equals to null for this particular sample input, right? For this particular sample input. So you are going to come out of your while loop and you are going to append the rest of the nodes that are left of the other linked list. Why am I saying that? See, this A, basically this particular linked list was already sorted. Let me just clear this. This particular linked list was already sorted and so was the case for this. So we reached till the null of this particular linked list, right? Now we were over here in this particular linked list. So can I say that no matter whatever data I have after this, let's say if after this I just need to check if my A is null. If I've reached to the last of A, I should make my curve dot bottom point to B. In this case, I will go to this else part and my curve dot bottom is will point to 50, right? So whatever is there after that will also will be there, but I just took it for an example, so I'm not adding that. Let's consider only these particular elements. So this is what you are getting if you observe, right? And if you see, this is in sorted order, right? What we are going to return? We are going to return res dot bottom. Why res dot bottom? Because this was your res. And if you return res dot bottom, you are basically returning your sorted linked list from here, right? So this was our aim. If you remember, this was our aim of the merge function. Great. So if you have understood the merge function, now let's try to see that recursive function that's going to help us to give our merge sorted list back to this other sublinked list, and that will finally help us to get our answer. Okay, so let's go to that. Yeah, so this is that function which is going to do all the recursive calls and help us to finally get our answer. Okay, so let's see. So let's take this sample input to understand this particular function. Okay, so initially what you are checking if your root is null or root dot next equals to null, right? So this will be passed as your root, right? So is it null? No. Is root dot next equals to null? No. Root dot next is pointing to 10, which is another node, right? Basically 10 is the data in that node, but it's a node, right? So both of this becomes false right now. Root is also not equals to null and root dot next is also not equals to null. So what you are going to do, you are going to call the same recursive function flatten on root dot next. Let me draw the recursive stack, okay, or the recursion stack. So initially you have 5, right? After that you are calling 10, right? And again after that what you are doing, you again go up and you check is root null, is root dot next null, both of them are false, so you are calling on 19. You again go up and check is root null or root dot next null. No, because none of them is true, right? Because 19 dot next, it will point to the node with the data 28. So you are again going to call on root dot next. So you are going to call on this 28, right? Now see what happens. From here the interesting thing begins. So over here your root is not null, but root dot next is null, right? Because 28 dot next, it has nothing. It's null. right? 28 dot bottom has data, but 28 dot next is null. So what you're going to do, you are going to return root. Fine. So what you're going to do, you're going to return basically this 28, right? Basically, you are returning the node. Please understand that you are going to return the node. I am writing the data present in the nodes, but this is actually a node, okay? I have just for easier visualization, I have written just the data, but it's actually a node, right? So I have just written a data in. So I have just written the data of all the nodes, but actually in this stack we have nodes, okay? So if you observe, this is a full node, which will have something over here in its bottom and next pointers, but it's a full node. So we are returning root, fine. So this is getting completed. This is getting completed. We are returning over here, right? So if you remember, from where did we call this? We called it from here, right? So that time it was 19 dot next, right? Or when I say 19 dot next, it's again the node at that point of time. Okay, for easy visualization, I have written just the data, right? So what you are doing in your 19 dot next, you are again storing whatever you have got. So obviously you're going to store this, right? Fine, basically this. So you are storing that and you are calling your merge function or on 19 node and 28 node, right? That's great. So after this, what will you be getting? If you remember our merge function, we were getting a node which was a fully sorted linked list head. Basically, you will get a node which is the head of the fully sorted linked list of all of this region, right? Of all the elements of this region. So once you get this, right? Once you get this, you're going to return root. Now, basically, this function call will get completed, right? This will get completed, and you're going to return the root of that. So basically, you are returning, if you remember, the head of the sorted linked list which contains all the elements from here to here. Okay, all the elements from here to here, okay, in a single level. Okay, so you're going to return this. Now from where did you get this call? You get this call from here, so you're going to return it over here. Great, let's see what happens. So this was your 10 dot next, right? That's the reason you got a call for 19, right? Because your 10 dot next was 19 if you see. So that call is finished, right? So you are returning it over here again. So what are you doing right now? Basically in your root dot next, you will have 19 as the head, right? And you will have all of these combined. So you're again calling on 10 and 19, but this time this 19 has all the elements. This 19 has all the elements, right? This 19 is not the only 19 with these many elements. No, it's not the case. This 19 has all the elements from here to here, right? So same thing will again work. Your merge will happen, right? And this time you will get the merge for all of this, right? And from where did this was called? Like if you remember, this will get finished and this was called from here, right? So you basically did 5 dot next, and that's the reason you called for 10, right? So when you return, so what you're going to do, you will have all the elements from here to here, right? But in a single linked list, right? That is at the single level. To be more precise, in a single level linked list, right? So that's great. You're going to do 5 comma 10, but this time this 10 will have, basically this 10 will be the head of that single linked list or single level linked list, to be more precise, that has all the elements, right? All the elements from here to here, right? So yeah, all the elements, just a second. Yeah, all the elements from here to here, right? So if this is clear, again the merge function is going to get called, right? Again the merge function is going to get called, and this time it will merge all of them, right? It will merge all of them. Like all of this will get merged, right? And where are you going to return this? Where are you going to return this? Basically, you are going to return this from where this function flatten was called, right? Like this will also get finished, and from wherever this function flatten was called, you are going to return the full and final linked list, okay, at a single level which contains all the elements. Yeah, so I hope this is clear to you. Now let's go and have a look at the Geeks for Geeks practice portal. All right, guys. So if you have a look at the code, this is almost similar to what we saw on the whiteboard. We had this merge function, right? It is the same merge function that we saw over there. So I think it does not need an explanation again because I have already explained it earlier. But still, if you have any doubts, you can comment it down. I will surely answer to them. After that, this is one more function, flatten, right? Which I have also explained on the whiteboard. So let's just compile and run this. All right, let's try to submit it. There you go. So we get the correct answer, right? So this was a very good question. Okay. I hope this is clear to you and I was able to do some value addition today in terms of coding. So let me know if you have any doubts, any queries related to the explanation or the question or anything related to today's lesson. Okay. So I will surely take those questions and answer all of them. Okay. Whatever you ask in today's explanation for this particular video. All right, guys. Thank you so much. Thank you for joining Geeks for Geeks practice.